105 pounds.
105 pounds.
It consists of 4 motors connected up to these spinning magnet arrays. And if you spin these fast enough, it will actually levitate.
That's correct. Are you ready? Let's fire it up.
It's lifting.
Okay, it's flying now.
Is it?
Yeah, go for it.
Now it is so easy to just move around. That's amazing.
Give it a push, like it's got some real...
Wow. It could carry some weight, hey?
Yeah.
That is amazing.
So how does it work? Well, it's similar to how a magnet falling through a pipe is slowed down. Anytime a conductor experiences a changing magnetic field, electric currents are induced in it which create a magnetic field to oppose that change. And in this case, the spinning magnets induce currents in the copper sheet. They create a magnetic field which is nearly a mirror image of the spinning magnets, and so they're repelled. If the rotors spin fast enough, this repulsion leads to levitation.
That is awesome.
All right, let's set it down again.
Yep.
It's just going to come gently land.
The magnetic field of the permanent magnets has to be very strong. Neodymium magnets are strong, but there's a special configuration you can use to make them even stronger. Magnetic field lines run from north to south, and they're normally symmetric on both sides of a magnet. But if you rearrange them like this, the magnetic field lines are channeled almost entirely into one side of the magnetic array, and they cancel out on the other side. This configuration produces a much stronger magnetic field without changing the properties of the magnets. In these rotors, there are 12 wedge-shaped magnets. Their magnetic poles are fixed in this particular arrangement. This increases the magnetic field on the bottom side and almost eliminates it on the top. As the magnets spin, they create a rotating magnetic field in the copper beneath them. This induces currents that create magnetic fields which oppose the magnetic field of the spinning magnets above. The result is a repulsive force that is effectively lift for this quadcopter. This principle has been used to achieve levitation in everything from maglev trains to hoverboards.
This is what makes up the majority of what a magnet is, and that of course is the inertia of counter space. The non-Cartesian or anti-Cartesian, we could say subspace or zero-point energy, it doesn't really matter. Of course, Mother Nature does not care what we call it. Let me put the magnet underneath the supercell here. Mother Nature doesn't care what we call it. Yes, everywhere we see light, that's where we actually see constructive interference. And we see the absence of light, we have destructive interference. Of course, this is the conjugate geometry of the entire universe. If I get down at a steep angle here and look at it, there we go. Actually see this holographic effect. We can look at a vortex that looks like a dip or a drain, where there is a complete absence of light at the center of this. It is like about a 1-inch neodymium. It's actually covered in plastic. It's not a very powerful one, but we see a complete and total absence of light, and that, of course, we could say human beings, due to science fiction movies, are used to seeing or thinking things in terms of subspace or zero-point energy. We all grew up with this jargon from Star Trek and various other science fiction, but we're looking at the conjugate geometry of the entire universe, the dielectric and the magnetic. Of course, the dielectric and the magnetic are one and the same thing, like ice and water are not two different things, they're just different expression modalities of water. Well, the magnetic and the dielectric are not two different things. They're one thing and one thing only. Here we have the constructive and destructive interference between the magnetic and the dielectric. Of course, everywhere we see the absence of light, we have destructive interference, i.e. the dielectric of everything vanishing into counter space, which of course is where it began to begin with. Light is a coaxial circuit, and of course it bends to the magnetic, but of course we're looking at nanoparticles of iron in a surfactant, and it's reacting to the light. I'm moving it so that it doesn't burn in an image, and I can show you a ring magnet in a second here. But here is where we have no magnetism at the center of this magnet. Now,